All right, hi everyone. I'm going to do a video on rates of change and limits. So some of the videos I'm going to do will be, like the YouTube videos that you're used to, the live ones. But for the beginning of the calculus, there is so much graphing involved that I thought it would be best if I actually use some graph paper to show you what's going on. So there are a couple things you're going to want for this lesson if you're going to take notes along with me. And one thing that you're going to want for sure is your calculator, and you're going to want to use graph paper, and then you're definitely going to want to use a ruler so that the graphs are just cleaner and easier to analyze. So the first thing that you need to remember about a limit is the word approach. So a limit is dealing with an approaching value. An exact value and an approaching value are not the same thing. So the most basic way that we can figure out what a limit is using, a direct substitution. So notation is the limit as x approaches c. That's supposed to be an arrow. Sorry, it's not a very good arrow. The limit as x approaches c of some function is going to be equal to a constant. It could be equal to an equation. That's going to depend on the function that we're looking at and what the value of c is. So x, we understand, is a variable. C is some constant. And I know that right now this probably doesn't make a whole lot of sense, but it will as we go through some examples. And the f of x is some function. Okay, so you have the limit as x approaches c of some function is going to equal to a constant or an equation or something along those lines. I'd like to go back to Algebra 2 Honors when we talked about geometric sequences and series. So if you recall a geometric sequence, the geometric sequence is something like, how about 4, 2, 1, 1/2, 1/4, etc., etc. That's a geometric sequence, and the reason it's geometric is because it involves multiplication. In this case, well, you're dividing by 2, but we never talk about division. We always talk about multiplying by a fraction. And we use r for the common ratio, so r would be 1/2. And just to review, if I was going to write the equation, an equation to represent this geometric sequence, the first term would be 4 times 1/2 to the n minus 1. And you can actually simplify that further. You would say 4 is 2 squared. Last time I checked. It's been a while since we've done math, but 4 is 2 squared. 1/2 is 2 to the negative 1 to the n minus 1. Oh, I hope you can see the pink color. And then distribute, use the power property of exponents. So you get t sub n equals 2 squared times 2 to the negative n, plus 1. Multiply terms, add exponents. I'm sure there is a much faster way to do this, but this is the way I'm doing it. Add exponents. So that's going to be negative n plus 3. Okay? Okay, so who cares? What does this have to do with limits? So when you first, well, not when you first learned, but when you learned how to do series, which is the sum of a sequence, remember that series is the sum of a sequence? And so you'd be asked to find the sum. Let's continue with the same sequence. I'm just rewriting it. So if I asked you to find the sum of the first two terms, which is kind of silly, but if I asked you to find the sum of the first two terms, that would be 6. And if I asked you to find the sum of the first three terms, that would be 4 plus 2 plus 1, which is 7, last time I checked. So here's what's going to happen. If I ask you to find the sum of the first, 9 terms, 10 terms, whatever, you could figure it out. However, this is what you really need to think about, and this is where limits really start to develop, or at least develop in terms of your mathematical knowledge so far. If I ask you to find the sum of n terms, okay, so bear with me. The first term would be 4. The second term would be 2. The third term would be blah, blah, 1. The fourth term is 1/2, etc., etc., etc. What's happening to the value of the term as you go on down the list? So if I ask you to find the 10th term, you would say, okay, that's 2 to the 3 minus 10, which is 2 to the negative 7. And I'm going to cheat because I have my calculator. 2 to the 7th. 1 over 128. Pretty small? Yeah? What if I asked you to find let's do the 30th term. So that's going to be 2 to the 3 minus 30, which is 2 to the negative 27. Yeah. I don't know what that is, but I know that it's really small. I know that it's really small. So what happens if I ask you to find the 40th term, the 50th term, the 60th term, the blah, 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 blah term? What's happening to the value of the term as n gets larger? What's happening to the value of the term as n gets larger? So the limit as, we'll use n, approaches infinity of 2 to the 3 minus n is 0. That's supposed to be an infinity symbol. Sorry, I'm kind of out of practice. The limit as n approaches infinity of 2 to the 3 minus n, which came from here, is 0. Great. But what's happening to the sum? What's happening to the sum? Okay, so the sum. So remember I asked you to find the sum of the first two terms was 6 and the sum of 3 terms was 7, blah, blah, blah. The sum of n terms. Okay, it's on my other sheet of paper, sorry. So 4 plus 2 plus 1 plus 1/2 plus 1/4 plus 1/8, blah, 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 blah. Okay, so what's blah, 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 blah? Exactly. Eventually you are adding 0. Well, when you add 0, does a sum change? Of course it doesn't. When you add 0, a sum doesn't change. So these values are getting smaller and smaller and smaller. So the term value is approaching 0. The sum of n terms in this particular sequence is 4 over 1 minus 1/2. Which is, I don't know, 8. Okay, so where'd this come from? The sum of n terms is equal to the first term over 1 minus r. This is what we call a convergent series. And this is a limit. This is a limit. The value of the term is getting smaller and smaller and smaller and smaller, such that you're adding, 1 over 2 to the 7th plus 1 over 2 to the 8th plus 1 over 2 to the 9th, blah, blah. They're getting so small that the sum is converging upon a number, which is called a limit. The easiest way to find limits, I know right now you're like, what's she talking about? Trust. The easiest way to find a limit is algebraically. Plug and chug, baby. That is by far the easiest way to go. So for example, if I ask you to find the limit as x approaches 3 of the function x squared plus 2. I'm just totally making this up, okay? So vocabulary, how do you speak this using proper English? The limit as x approaches 3 of x squared plus 2. That of matters, okay? So how do you do this? Plug in 3 and you get, I don't know, 11. You're gonna be able to catch all my mistakes and I'm not gonna hear you, Ms. Babiak, you made a mistake. Sorry. Okay, let's do another one. Let's say I ask you to find the limit as x approaches, how about -4 of 2x cubed minus 3x plus 9. Okay, plug and chug. 2 -4 cubed minus 3 times -4 plus. All right, give me a second here. I've got my handy dandy calculator. You should be doing this with me. -4 cubed times 2 plus 12 plus 9. I got -107. Hopefully that's right. I got -107. Okay, before I go on, x squared plus 2 is a parabola. Vertex at the origin. 2x cubed minus 3x plus 9 is a cubic. It has down up end behavior. Y-intercept is 0, 9. Okay, so this is going to matter when we start to find a little bit more complicated limits. Having an idea what the graph looks like is going to be super helpful. Okay. All right, piecewise functions. Woohoo! Everybody's favorites. Remember this, you're going to graph a piece of each function. So let's say we have, how about absolute value of x plus 3. And this is going to be for x is less than, how about x is less than 5? -6. Okay. And then let's do x squared for, no, let's do x squared minus 5 for -6 is less than or equal to x, which is less than 0. I have a feeling this isn't going to turn out to be very pretty, but that's okay. And then let's see, has absolute value. That would be parabola down 5. Let's do x minus 1 for x is greater than or equal to 0. Okay, I'm going to graph a piece of each function. I think what's helpful for me is to understand that this first piece is going to be a piece of a parabola. The second piece is going to be, I misspoke. The first piece is going to be a piece of an absolute value graph, which is a V. I misspoke. The second one is going to be a piece of a parabola, and then the last one's going to be a piece of a line. This might be a good place to pause the video and see how much you can graph by yourself. I'm going to go ahead and do it now. I don't know how to pause a video while I'm in the middle of making it. So if any of you know how to do that and could teach me how, that would be fantastic. Okay, so plug in -6. -6 plus 3 is -3. Absolute value of that is 3. 1, 2, 3, 4, 5, 6, 1, 2, 3. I only want the values of x less than -6. So some people are like, oh, well, here's the other part of the absolute value. That's not true because that's greater than -6. If it helps you, plug in another value. Plug in -7, you get 4. Plug in -8, you get 3. Okay. X squared minus 5, that's a parabola. I think I chose numbers that are way too big, didn't I? Oh, I did. We need to change that, otherwise it's not going to fit on our graph at all. Okay, well, that's why I use erasable pen, people. Let's change this. Let's change this to -2. Yeah, that doesn't work at all. Sorry. Change it to -2. Plug in -2, you get 4. 4 minus 5 is -1. So -2, -1. Plug in -1, you get -4. Plug in 0, you get -5. 1, 2, 3, 4. Okay, and I made 2 mistakes. Not or equal to. This should be an open circle. Not or equal to. This should also be open circle. Okay. Hey, check that out. Not bad. And then plug in 0, you get -1. 0, -1. And this is a closed circle. Okay. Since we're here, let's review domain and range. The domain, you can get the domain straight from here. Let's do, let's practice using interval notation. So we're gonna have -infinity up until 6 in union with -2 to infinity. And -2 is included. That's a bracket. Then we have the range, which I believe is going to be, that's 1, 2, 3, 4, 5. -5 to infinity. Okay. Here's where we're going to start looking at the difference between an exact value and a limit. If I ask you to evaluate the f of -2. X is -2, closed circle. The f of -2 is -1. Okay, how about the f of 1? The f of 1 is 1. If you look at your graph, 1, 1. Okay, so here's the big one, and this is where you should be putting the star on your piece of paper. This is the biggie right here, okay? This is where we're going to talk about limits and exact values and approaching and not approaching, whatever. If I ask you to find the f of -6, the f of -6. Okay, well, -6, you have an open circle. So I look at this as it's a pothole. So for those of you who drive, you drive along and you hit a pothole and you approach the pothole, which is great, but until you your tire hits the pothole, then things aren't so good. This is undefined. You don't want to step in the pothole. Or think of it as you're walking to school, you're walking to class. And you step on you can approach the curb, but you step on the edge of the curb, that's not so good. You're going to have a sprained ankle. How about the f of 0? Oh, the f of 0. Okay, that's the y-intercept essentially. This is the same thing as the y-intercept. You have here, but you also have here. One of those is exact and the other one is not. And if you said the closed circle, then you were correct. The f of 0 is -1. Closed circles are okay. All right, ready? What if I asked you for the limits? Okay, let me write this down for you. Okay, so first thing you need to know is notation. More notation. Those of you who have messy handwriting, and if we were in class, I'd be making fun of some of you, but we're not in class, so I can't do that. The limit as x approaches c, and it has a superscript that looks like a negative sign. This is the limit as you approach from the left. The limit as you approach from the left. So it looks like it's a superscript. The limit as x approaches c with the superscript, that's a plus sign. So I'm sure you can connect the dots that this is the limit as you approach from the right. You have a left-handed limit. They call it left-handed. They call it a left-handed limit and a right-handed limit. All right. So here we go. I want to know what is, I already asked you for the f of 0. That's the exact value. But now I want to know the limit as x approaches 0 of this function. This whole thing's a function, f of x notation. This whole thing's a function. Whew. This is a trick question. Let's look at it from two sides. Let's look at it first as the limit that we approach 0 from the left. Let's try that first. As I approach from the left, so I'm not sure, can you see my hand? Okay. So I'm moving from the left toward the right. This is very confusing for some people. From the left, the negative values are on the left. I approach from the left towards the right. Okay, so I don't know if you can see, I use different colors, but the orange. So if I'm on this function, and I'm on the function, and I'm coming from the left, first thing I am is on this absolute value graph. And then I jump off the absolute value graph, and I'm on this parabola, and I'm sliding down the parabola, and I end at negative, what is it? I forgot what it was. Negative 4, 1, 2, 3, 4. Negative 5, 4. I can't count. 1, 2, 3, 4, 5. I am approaching negative 5. The exact value is not negative 5. The exact value is negative 1, but I'm approaching, and that is what by definition of a limit is. It's a value that you are approaching. It's like, think of it, you know what? It's like an asymptote. It's a value that you approach, but you never touch. Okay, well, here we go. I'm approaching negative 5. So when I come from the left, I'm approaching -5. Great. Now I'm going to approach from the right. So right, positive values are on the right. So I'm on my graph and I'm coming from the right and I'm approaching 0. And as I approach 0, I'm approaching -1. What's the overall limit? Okay, what's the overall limit? If I'm coming from the left, I'm approaching -5. If I'm coming from the right, I'm approaching -1. Therefore, some of you are going to be so excited from that movie from like forever ago, Mean Girls, and they're talking, she's like in the competition at the end of the year and they're talking about limits. The limit as x approaches 0 of the function does not exist. And I'll give you a synopsis after you have an opportunity to write this down and I have an opportunity to change my paper. Okay, I'm going to turn my paper. All right, so let's just kind of summarize this. You have the limit as x approaches some constant from the left of a function. And you have, leave a little space, and you have the limit as x approaches c, some constant, from the right of a function. If these two are not the same, how about if the limit as you approach from the left does not equal the limit as you approach from the right, then the overall limit of the function does not exist. And you can abbreviate DNE. Does not exist. Okay, so I have the book in front of me. I probably should have told you to get your book, but I want to look at a couple other examples where I don't want to graph it. Frankly, I don't like to graph. I think graphing is awful, but you want to be able to find the limit algebraically so you don't have to graph, etc. So I want you to find the limit as x approaches 3 of x squared minus 9 over x minus 3. Great, plug in, right? Isn't that what I told you to do? You plug in and you get 3 squared minus 9 over 3 minus 3, which is undefined. So you say the limit doesn't exist, but it's not true. Factor, 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 factor. Factor, factor, factor. So here's what's going to happen. You know, we talk about the holes and the removable discontinuities and blah, blah, blah. And then you reduce. Just because you are not with me anymore does not mean you get to say that other word. We reduce. Well, when you reduce, what do you get? You get a hole. Can you approach a hole? Yes, you can. Can you approach a hole? Yes. This is when we graphed all those rational functions in Algebra 2 Honors and they were like crazy and there were 16 asymptotes and 15 holes and blah, blah. This is a hole and the hole is at 6. All right, let's do another one with complex fractions. Let's find the limit as x approaches 0. If you're looking in the book, this is number 28, if you're following along. I'm asking you to find the overall limit, not the right hand, not the left hand, the whole thing. Plug in, awesome. Nope. If you do a straight plug in, 0 in the denominator. Never, ever, ever, ever in your entire math life can you have 0 in the denominator, ever. But I can simplify this. So the common denominator between 2 plus x, 2, and then 1. The common denominator is 2 times the quantity 2 plus x. So I'm going to multiply everything by the quantity 2 plus x. And that gives me, reduce, you get 2 minus quantity, 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 parentheses matter. Parentheses in math matter. 2 plus x all over x times 2 times 2 plus x. Reduce this out, simplify, do the math, which I'm more than confident that you know how to do. This is negative x over 4x plus 2x squared. I made a mistake. That gives me with 2 minus 2 plus x over 4x plus 2x squared. I feel like I made a mistake, which you probably can recognize it right now. Oh, I can see it. Whew. Thank goodness I caught that. Factor out an x. That leaves you with 4 plus 2x. Reduce, and you're left with negative 1 over 4 plus 2x. Plug in 0 and you get negative 1/4. Oh, I was nervous there for a minute. Okay, last thing we're going to do is the calculator. Last thing we're going to do is the calculator. Oh, sorry. I should leave my... Okay. Sometimes it's not easy to find the simplification of the limits. Is it approaching x, y, z, blah, blah, blah. So you definitely want to have your calculator handy. So let's do... Okay, if you're following along, this is number 36. Limit as x approaches 2 of x plus 1 over x squared minus 4. Okay? Great, plug in, doesn't work. Sorry, this is pretty bad handwriting. I'm using my nifty, handy dandy new erasable pens. Very excited about these. Okay. You can factor. It's not going to do any good because nothing reduces out. So let's plug it into our calculators. Parentheses x plus 1 divided by parentheses x squared minus 4. I have no idea what I was doing on my calculator last, so I'm going to do a zoom 6. Okay, so I want to know what's happening when x is 2. Let's just take a look at the calculator. Remember, the left hand must equal the right hand. The left hand limit must equal the right hand limit. So hopefully you can see my pen. I care about the middle. That's where 2 is. 2 is right here. If I'm coming from the left, I'm in this middle piece that looks kind of cubic. It looks cubic, but it's not really a cube. Keep that in mind. So as I'm coming from the left and I'm approaching 2, The graph is going down, 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 down. What is that? It is negative infinity. So the limit as x approaches 2 from the left of this function is negative infinity. Let's try going from the right. So I'm coming from the right-hand side. So this is the limit as x approaches 2 from the right. And that's going to be, you're coming this way, and you're going up. Are they the same? Does the left hand, negative infinity, equal the right hand? And the answer is no. D and E. Okay, so this really is all of section 2.1. Your homework is split up over 2 assignments. One of them is assigned Monday, and the other one is assigned like Tuesday, Wednesday. So this should cover everything. However, obviously you're still going to have questions. Go on Classroom and post the problems that you're having. I need to see number 6. I need to see number whatever. Okay, so get on Classroom and let me know which ones you're having problems with. If you feel comfortable and you can do both assignments, great. Just make sure you're posting the assignments individually as they show up in the stream. All right, you guys, I miss seeing you and laughing and having a good time together. I hope that you are, doing everything you can to stay healthy and communicate with your family and your friends. And I will see you, I hope, via YouTube soon.